Thanks, everybody. My name's Aaron Gallimore. I'm Senior Director Cloud Engineering at Global Payments.
Yeah, hi, I'm Andy Devine. I'm a Principal DevOps Engineer and Networking Specialist here at Global Payments.
Thanks for your time today. Today we're going to talk about how we've used Route53 profiles, a global transit network, to consolidate numerous VPC endpoints into a centralized solution to help us reduce costs, capacity, improve security. And at the same time, we'll touch on our multi-account strategy, hub and spoke VPC structures, and how we've used Route53 profiles, which is a new feature as of April this year, to help with the migration and some future plans going forward. So just a little bit about who Global Payments are. So we're a global payments, or leading payments technology company. We operate in over 145 countries worldwide. We're the leading issuer processor in the US, UK, Canada, Ireland, and China, and we process over 75 billion transactions a year. So we touch a lot of people's daily lives with our mission critical systems. And finally, just to set the context, we've been on our cloud journey for about 8 years now. Just to touch on what VPC endpoints are, for those who are maybe not familiar with it. A VPC endpoint is a network interface which sits inside of your VPC network to give you access to AWS shared services. So what otherwise would have been publicly available through URLs or global URLs, instead you can resolve services inside of your network to keep that network traffic private. It does that by placing a network interface inside of your VPC. For us, this is a sort of a standard practice that we've adopted since the beginning of our cloud journey, and sort of as a result, we've continued to accrue VPC endpoints over what is now hundreds of VPCs across our 7 AWS regions that we leverage, and that's equated to ultimately over 13,000 endpoints over that time. So what are we talking about today? So our initiative was about really a cost-saving exercise. Our VPC endpoint usage represented probably the 5th biggest cost on our AWS bill over the last 12 months. That was really only beaten by EC2 marketplace and savings plans. And secondly, for a Fortune 500 company like Global Payments, IPv4 RFC 1918 address space is a premium, and every single one of those VPC endpoints inside of a subnet, inside of a VPC, takes up 1 IP address space. So that's a lot of IP addresses for us to give up. So we hope to be able to claw some of that back as well. And lastly, it's a bit of a security play as well. Access today, for anybody who's used VPC endpoints will know, VPC endpoints are regional. So if you want to consume a service in another region, you have to provide a way of transiting over the internet to be able to access those endpoints. So we're hoping this solution also gives us a way of removing that requirement of transiting over the internet and accessing more locally. I'm going to hand over to Andy and talk about the technical approach.
Yeah, thanks, Aaron. So this design just shows sort of at a high level the components that were involved for us to centralize all of our VPC endpoints. So the key enabling technologies are AWS Transit Gateway, the VPC endpoints themselves, which we placed in an endpoint hub VPC within our shared services account. We used Route53 profiles. This is in order to share the private hosted zones with all of our application accounts in order for them to resolve those VPC endpoints within that centralized VPC. And we leverage Resource Access Manager. We do that to not only share the profile, we share prefix lists as well, which we manage to help kind of consume those centralized VPC endpoints. And as you can see, the endpoint hub VPC there, we actually use RFC 6598 address space for that hub VPC. This is the carrier grade NAT range. Again, this is due to our sort of shortage of RFC 1918 space. So that IP address range is routable within within our AWS environment, and our endpoints were all addressed from that IP address range. Our application account and spoke VPCs, they're all addressed from RFC 1918 to give that full reachability for on-premise, etc. So yeah, next slide, please. So yeah, one of the key enabling technologies for us is AWS Transit Gateway. At the moment, we operate a hub and spoke topology within every AWS region in which we operate. And we also have a full mesh of TGW peerings between all of our transit gateways. This enables sort of full routable access between regions and is a sort of key facilitator for accessing centralized VPC endpoints across region. So this cross-region routing that we have in place, this is static routes at the moment with those GDW peers. That combined with Route53 profiles, and those Route53 profiles contain all of the regional zones that we've created for our centralized VPC endpoints. That enables cross-region access to AWS APIs. So this has the benefit of keeping all of that traffic on the AWS backbone without having to traverse the public internet and use forward proxies or internet gateways to have that access to cross-region APIs. Next slide, please. So the VPC endpoints themselves, like I say, we created an endpoint services VPC in our shared services account using that carrier grade NAT range. Now there are VPC endpoints for many AWS services, but we didn't create a VPC endpoint in that centralized VPC for every AWS service. What we did, we looked at our existing estate and established what were the most commonly used VPC endpoints within our spoke VPCs, and we've created VPC endpoints for those. As part of creating that VPC endpoint, to facilitate this design, one of the key points is to disable private DNS, so the AWS don't deploy the managed private hosted zones. So when you use VPC endpoints and private link, there's often a checkbox for private DNS. And if you check that box, what AWS do is that they create a private hosted zone, which is not visible to you within the Route53 console, but it sits there and is associated with your VPC, and that has the effect of redirecting traffic to your local VPC endpoints. So normally when you're operating in your spoke VPC, for example, ec2.useast1.amazonaws.com, AWS would create that as a managed private hosted zone and alias the zone apex record to the IP addresses of your local VPC endpoints. So in our centralized VPC, we wanted to disable that option so that we can create the equivalent zones ourselves. That gives us the capability to then associate them with our Route53 profile. So what we also did was we created a managed prefix list. We created two managed prefix lists, one that references just the within region, the local region's centralized endpoint services VPC CIDR blocks, but we also created a global one. So for teams that want to leverage cross-region access to APIs, they can reference that global prefix list within their security groups in order to cover access to those VPCs. Finally, we created also a security group that references those prefix lists as part of our VPC module. So we use Terraform extensively for infrastructure as code. We have a standardized VPC module, so we added the security group in there. This just makes it convenient for applications teams to attach that security group to their workloads. That security group then just contains the egress rules required to access that endpoint services VPC. Next slide, please. So yeah, as Aaron alluded, Route53 profiles is a relatively recent product release, which really is something that's helped us on this journey to minimize the amount of sort of zone associations that we would have had to do prior to the release of Route 53 profiles. So first of all, what we did was we created Route 53 private hosted zones for all of our VPC endpoint regional DNS names. And then we associated those originally with the endpoint services VPC. The next step is to create an A record at the zone apex. So what we do then, for as an example, that ec2.useast1.amazonaws.com, we create that as a zone, but we also create that as an A record within the zone, which is then an alias to the corresponding VPC endpoint within that VPC. We create the Route 53 profile. Again, this is centralized within our shared services account. And what we do is we associate all of the private hosted zones that we've created globally with that Route 53 profile. The Route 53 profile is then shared using Resource Access Manager, and then we have some code within the VPC module which actually does the association of that Route 53 profile to the VPC itself. Yeah, next slide, please. So yeah, Resource Access Manager, like I say, we use this to share the Route 53 profile, and we share that to all account principals within our organization. So this makes it visible within all of the application accounts. We're currently using the sort of AWS managed permission, which allows the association of that profile to a VPC. It's effectively a read-only permission at the moment. So whilst you can associate the profile to your VPC, you don't have permissions using the sort of default managed permission to attach your own zones within your application accounts to that profile as well. So we are looking to extend the usability of that profile to allow application teams to associate those zones, but just to facilitate centralized VPC endpoints at the moment, we're using that managed permission. We also use Resource Access Manager to share these prefix lists that we created. Like I say, we created 2 prefix lists, one for regional endpoint VPC side as one for global. So that's all visible within application accounts. So they, the application teams can leverage that that prefix list within their security groups. So, next slide, please. So yeah, in terms of the sort of technical approach to the actual endpoint migration, the default Route 53 profile prioritization helps us with this migration because existing managed private hosted zones take precedence. So like I mentioned, if you are running a local VPC endpoint within your VPC, AWS, all of our VPCs, their applications teams will have vended these VPC endpoints as part of that Terraform module. And by default, that enables the private DNS option, which means that AWS created this managed private hosted zone. So by default, that's associated with their VPC. We associate the Route 53 profile, which also contains the same private hosted zone name, but the VPC rule takes precedence. So this is good because this means that we can attach the profile, but there's no disruption, there's no interruption to traffic flows within our application teams VPCs, and it allows and sort of facilitates this sort of phased migration that's the application teams can do this migration at a time that suits them. So as part of that sort of migration, we have some pre-migration testing just to make sure that the Route 53 profile is successfully associated. And we also advise the teams to do the actual connectivity tests within their VPC as well. So we just provide on a centralized documentation page and help page these commands so that you can check the Route 53 profiles are actually associated with the VPC. The application teams can then connect to an EC2 instance within their VPC and run an AWS CLI command on that EC2 instance where they actually hard code the endpoint URL. So as well as when you create a VPC endpoint in the shared services VPC, in the centralized VPC, you actually get a AWS kind of ephemeral VPC endpoint DNS name as well as the actual friendly name. So if you hard code that into the endpoint URL command, that will actually prove out the egress connectivity. So this proves out that you've got the appropriate security groups on your EC2 instances and that all of the necessary routing is in place. So once all of those pre-migration tests have been completed, then application teams just need to effectively delete the local VPC endpoint. And then once that local VPC endpoint and associated AWS managed private hosted zone has been removed, then the hosted zone that's associated with the Route53 profile will then start being used. At this point, DNS queries, instead of resolving to local VPC ENIs, will start resolving to the centralized VPC ENIs. Yeah, next slide, please.
So the project didn't come without its own challenges. As I mentioned right at the beginning, we're a Fortune 500 company with over 27,000 team members worldwide, and applications and systems have been deployed over the last sort of 8 years. So there was an awful lot of environment, systems, platforms, team members to touch base with and actually to migrate. So the best way that we could do to help with that was to make it as easy as possible. You know, we did road shows to all of those application teams. We wrote migration guides. We demonstrated all the benefits because, of course, you know, every endpoint that gets removed, there's a cost saving associated with it. And we delivered some of those tools that Andy's talked about there to really reduce the risk of any sort of outage, let's say, as part of a migration. Downtime, there was some. Whenever we moved away from a distributed endpoint to a centralized one, there is a finite amount of time where DNS needs to converge and the actual endpoints need to be removed from under the covers. That for us is really important because, you know, we manage mission critical systems, so there is a level of coordination required to do that. The last one is really about security rule limitations. We run a converged service wherever we can and host applications co-located within the same EKS environments, containerized systems, etc. Whenever we added additional security group rules to what is already a very large number of rules, obviously there's risks of hitting limits and quotas there. So what we did was we broke those down. Instead of it being a global prefix list that included every single CIDR of every VPC that we have globally, we instead broke that down to regional lists so that they could be targeted specifically by application teams for the ones that they needed.
Yeah, like I say, I think we alluded to this before, some of the challenges of Route 53 zone associations. So prior to Route 53 profiles, what we would have to do is associate every private hosted zone individually with every application VPC. And as you can imagine, you know, we operate in many regions, and we I think around 30 VPC endpoints we've created in the centralized VPC. So that soon equates to a huge amount of zone associations that we would have to do prior to Route 53 profiles. The diagram on the right kind of shows this sort of full mesh of zone associations that you have to make if you don't leverage Route 53 profiles. Route 53 profiles gives us a sort of more of a hub and spoke architecture for DNS, which then, you know, more aligns with our actual network architecture where we're using transit gateway and a hub and spoke environment. So we'll use Route 53 profiles to associate, you know, application teams, private hosted zones, as well as the centralized VPC endpoint zones. This will hopefully give us a common view of DNS across all VPCs. At the moment, the sort of view of DNS can be fragmented because we tend to have a lot of ad hoc zone associations, whereas this will give us a more centralized view. It's quite laborious doing a zone association as well. At the moment, that's 2 pull requests for us. The first pull request is to create the zone association authorization, because these are going across account, and then another pull request to actually do the zone association itself. Next slide, please. So yeah, our next steps is really to look to help application teams leverage Route53 profiles so that they can associate their own private hosted zones. This again, like I say, will give us that common view of DNS, and yeah, just to accelerate the adoption of centralized VPC endpoints. Keep doing those announcements and making sure that everybody's aware of our new sort of facility. Yeah, thank you.
And that is us for today. Thank you, everybody, for listening. There's myself and Andy's LinkedIn profiles there if anybody would like to get in touch with us after, ask any other additional questions.